All right, so on to the note on normal distributions. So the normal distribution is symmetrical and unimodal. So unimodal means it has just one hump, one mode. This bell curve occurs so often that statisticians consider it to be normal. So it's called the normal curve. Since the distribution is both symmetrical and unimodal, the mode, the median, and the mean are all equal. They're all the same thing because it's perfectly symmetrical with just one mode. This distribution can completely be described by its mean and its standard deviation. All right. So if we can calculate those two values, then we know all the information we need to know about the data, which is pretty remarkable if we have a normal distribution. The smaller the value of sigma, the smaller the distribution, the more the data clusters around the mean. So on the right-hand side, we've got a smaller distribution, and so it's not as widespread. It's narrower. So the note says the smaller the value of sigma, the more the data clusters around the mean, which results in a narrower bell curve. Whereas the larger the value of sigma, the standard deviation, the data is more dispersed, resulting in a wider bell curve. So for any given distribution, this is pretty remarkable. It doesn't matter what the shape is. If it's a normal distribution, we get three key values here. We get a 68%, a 95%, and a 99.7%. This is very significant. We're going to see this again and again. But it says that 68% of the data values of X will lie within mu minus sigma, mu plus sigma. So we're saying that 68% of all data values lie within one standard deviation of the mean. So we take the mean, we add that standard deviation to it, we subtract it, and between those two values lies 68% of our population. You get 95% of the data lies within two standard deviations, and 99.7% of the data lies within three standard deviations. So this is where often, if you hear on the news, they will report survey results, often results of polls, and they'll talk about, they often refer to a 95% accuracy. And that's because when they're doing their polls, they create them in such that their data is able to be analyzed using a normal distribution, and they report their results to two standard deviations. Typically, you'll hear that number again. You'll often hear that number. So that's where that comes from. So that's the key idea. We need to be able to calculate our means, our standard deviations, and then we're going to be looking at how we do 68, 95, and 99.7, or 1, 2, and 3 standard deviations. So what we'll do is I'll go on and I'll record a couple of different sample questions, examples that we can look at.